Okay, so conjugate of a complex number. Two complex numbers which differ only in sign in the imaginary parts are called the conjugate. So for example, if 4 plus 3i is a conjugate, then, if 4 plus 3i is a real number, then 4 minus 3i is the conjugate. Likewise, 2 minus 3i is a real number, then the conjugate to that, and the conjugate is denoted by a bar above it, would be 2 plus 3i. Okay, it was just the number. Conjugates have to have an imaginary part. So example would be 4i minus 4i. The conjugate of minus 4i is plus 4i, or the conjugate of I is minus I. So the conjugate is change the sign of the imaginary part only. So change the sign of the imaginary part, okay, to find out what the conjugate is. Okay, so what's explained here is what happens when you add a number to its conjugate. So for example, 2 plus 3i is z, and z bar is going to be 2 minus 3i. Now when you add a number to its conjugate, what happens is you're going to get 2 plus 2, you're going to get 4. And what happens is the imaginary part disappears. When you multiply a number by its a complex number by its conjugate, what happens here is you're going to get 2 times 2, 4, you're going to get minus 6i, you're going to get plus 6i, and then you're going to get minus 9i squared, which is going to be plus 9, because it's going to be minus 9 times minus 1, which is plus 9, and then you're going to get 13, and the minus 6 cancel off. So once again, you're going to get a real number, and basically everything disappears. Now, division of a complex number. When you're dividing a complex number, multiply the top and the bottom of it by the conjugate of the bottom. This will convert the complex number on the bottom to a real number. Then the division is then performed by dividing the real number on the bottom into each part of the top. Let me give you an example. An example will be question 3. In question 3, what we do is we write down this. We can see that it's a division line, so it's 1 plus 5i divided by 3 plus 2i. We then look, and remember, if we have to multiply the top and bottom by the same amount as so not to change the number. So I'm going to find out the conjugate of the bottom number, which is 3 minus 2i. Then I'm going to multiply the top and bottom by 3 minus 2i. And what this will do is it will turn the bottom number into the bottom complex number into a real number. And I haven't affected the overall value of this here because I'm multiplying the top and the bottom by the same amount. So let's quickly multiply this out. And what we're going to get is 3 minus 2i plus 15i minus 10i squared. And then on the bottom, we're going to have 9 minus 6i plus 6i, and then we're going to have minus 4i squared. Now, minus 10i squared is plus 10, minus 4i squared is plus 4, because remember, I squared equals minus 1. So we're going to have is 10 plus 3 is 13, minus 2i plus 15i is 13i. On the bottom, the 6i's cancel, and we get 9 plus 4, which is 13. Then we have 13 plus 13i divided by 13, which is basically divide everything by 13, and we're going to get 1 plus I. Because 13 divided by 13, 1. 13 divided by 13, 13i divided by 13 is 1i. Okay, so that's basically the use of the conjugate. Okay, so now we're going to do question 8. And question 8 is 3 plus 4i divided by 1 minus I. Now remember, what we got to do is we got to multiply the top and bottom by the conjugate of the number on the bottom, the denominator. So we're going to get 1 plus I this time. This one here is also going to be 1 plus I. We're going to multiply this out, and we're going to get 3 times 1, 3, 3 times I, 3i. Then you're going to get 4i times 1 plus 4i. Then you're going to get 4i times I, which is plus 4i squared. And then on the bottom, what we're going to get is 1 times 1, which is 1 times I is plus I. Then what you're going to get is minus I times 1, which is minus I, and then minus I times plus I, which is minus I squared. Now, what happens here is we get remember what I squared means. Minus I squared is going to be plus 1. Plus 4I squared is going to be minus 4. So we're going to get 3 minus 4, which is minus 1. 3I plus 4I being 7I. And then over here we're going to get 1 plus 1. It's going to be all over 2. Now it says in the form A plus BI. So it means we have to separate out the fraction. So it's going to be minus a half plus 7 over 2I. Remember, the fraction line can be joined together or separate. Okay. Okay, so number 10. If P plus Qi equals 2 minus I, 1 minus 2I, where PQ is element R, means they can be fractions or negative numbers, evaluate P squared plus Q squared. So what we do here is we use the division of a conjugate. Okay, so we have 2 minus I, and then what we can do is we multiply the top by 1 plus 2I and the bottom by 1 plus 2I. Multiply the top and bottom by the conjugate. Then we're going to get 2 plus 4I minus I minus 2I squared. Minus 2I squared being minus 2 times minus 1, which is plus 2. So we can change that right away. And then the next one's going to be 1. 1 times 1 is 1. 1 times 2I plus 2I minus 2I minus 4I squared. And we know about minus 4I squared, it's the same thing as plus 4. Because once again I is minus 1. Then we're going to get 2 plus 2 is 4. 4I minus I is plus 3I. Then we get 2I minus 2I, so we're going to get 1 plus 4 is 5. So we're going to get 4 plus 3I over 5. Separate out the fraction, we get 4 fifths plus 3 fifths I. So what P ends up to be, P is the real part and Q is the imaginary part, so P is 4 fifths, Q is 3 fifths, and then what we're going to get there is we're going to get we have to find out what P squared plus Q squared is, so it's going to be 4 fifths squared plus 3 fifths squared. Put that into the calculator and you find it equals the number 1. Okay, so that's no bother there. Now we're going to move on from number 10, and we're going to go on to number 13. Okay, so number 13, we have to simplify 2 plus I over 1 minus 2I. So once again it's a division question, and once again we are going to do the conjugate. 1 plus 2I divided by 1 plus 2I, and we're going to multiply that out, and we're going to get 2 plus 4I plus I plus 2I squared. Remember about that 2I squared, same thing as minus 2. Then on the bottom we're going to get 1 plus 2I minus 2I, and then it's going to be minus 4I squared. Minus 4I squared is going to be minus 4 times minus 1, which gives me plus 4. Then what happens here is we're going to get the 2i's cancel. We get 5 on the bottom, and we get 2's cancelled on top, and then we're going to get 4I plus I, which is 5I. 5I over 5 gives me I. So now we know that this full part in here is I, and now we're simply asked to get 3 times I to be squared. I squared is going to be minus 1, and 3 times minus 1 is minus 3. Okay, so this one here is 14 part 3, and 14 part 3 we're going to have to find out first and foremost, it's whatever is in the brackets to the power 6. We're going to work on what's inside the brackets. So we're going to have 1 minus 1 plus root 2I, and then underneath we're going to have root 2 plus I. We're going to do what we've done all this time, is we're going to multiply the top and bottom by the conjugate of the bottom, which is root 2 minus I. Then we're going to multiply in. Minus 1 times that is minus root 2, minus 1 times I plus I. And then we're going to get root 2 times root 2, root 2I times root 2, which is going to be plus 2I. And then we're going to get root 2I minus I, which is going to be minus root 2 I squared, which is minus root 2 times minus 1, which is plus root 2. See that our root 2's have cancelled. On the bottom we're going to get root 2 times root 2, which is 2. Then we're going to get minus root 2I plus root 2I. Then on the bottom it's going to be I times I, which is minus I squared. Minus I squared is 70 is minus minus 1, which is going to be plus 1. Then we're going to have 3I divided by 3. That gives us I. And then this thing here becomes I. Then we have I to the power of 6. And I to the power of 6 is I6. And I6 is the same thing as I2 to the power of 3, which is minus 1 to the power of 3, which is going to give me minus 1. Okay. Now, number 15 has letters in it. So once again, we're going to zone in on what's in the brackets. Okay, so we have a quantity to the power of 4. So this quantity to the power of 4. So you're going to work on what's in there. You're going to have A plus BI. You're going to have B minus AI on the bottom. You're going to multiply the top and the bottom by the conjugate of the bottom. And we're going to see what happens. So we're going to have A times B, which is AB. We're going to have A times A, which is going to be A squared I. We're going to beat BI times B, which is going to be B squared I. And then we're going to have BI times AI. So BI multiplied by AI is going to be ABI squared, which is the same thing as minus AB, because I squared is minus 1. The AB is cancelled. And then we're left down the bottom with this. We go B times B is B squared plus ABI minus ABI. And then it's going to be AI times AI, which is minus A squared I squared, and that's going to be plus A squared. They cancel, and what we're going to be left with is A squared plus B squared times I on top. So what I did there was I factorized out the i's, and then on the bottom we're going to have A squared plus B squared, and lo and behold it turns into I. Then it's this number I to the power of 4, and what we know about I to the power of 4, it's the number 1, or it's I squared to be squared, which is minus 1 to be squared, which also gets you plus 1. Okay, so that's 15 done. Now we're going to go on to, we won't do number 16, we've seen number 16 is the same thing. Basically for number 16, just put in Z1 and you get minus 2 plus 3i, then do 3 plus 2i on the bottom, and then that's this part here, and then you're going to power to 5 the answer, and then just repeat the same procedure the last two questions by multiplying top and bottom by the conjugate. Once you get this answer, then just do it to the power of 5. Okay? And then you're okay. Now, moving on.